The idea for the virtual lab came kind of interestingly. I was working on a research project with a local microelectronics company, and during a break I was talking with a hiring manager and discussing how we could better educate our students so that they could be more functional when they came to work. And his viewpoint was that they didn't get enough practice in the recursive process of design of experiments. In a university lab, the project is teacher defined. The emphasis tends to be on getting the experimental apparatus to work, to performing the experiment. And if we look at how the students view this, they may even view the performing the experiment as such. So what we do with the virtual labs is use them as a way to complement the physical labs by minimizing the effort it takes to perform the experiment and thereby freeing the students' cognitive load to design the experiment, analyze, interpret data, and draw conclusions.
Now, my name is Philip Harding. I'm the Linus Pauling Engineering Chair in the School of Chemical, Biological, and Environmental Engineering. It's been my pleasure to adopt the virtual lab educational strategy with the senior lab sequence we teach here. It's been an opportunity to both reduce costs by eliminating physical lab expenses while also improving the scope and breadth of the lab teaching by driving students towards more iterations and learning the scientific process.
The students liked the experience. In fact, when they first saw the interface with the program, they were very much into it because it was very video game-ish. That has value too because it adds to the authenticity. The user navigates through the virtual lab just as real technicians would in a fab.
I use the virtual lab for Chemi 414. Senior lab class. It was our second lab, and the first thing we did was we did a bunch of research. We tried to find what common process temperatures there were, common process pressures, and the flow rates we determined by doing mass balance. So we didn't do anything in there until we had that all done.
Approaching the virtual CVD was really nice for me as a design project because I had just come back from an intern in the same industry. I worked all summer long with a real CVD, and so that really helped me with my virtual CVD. I thought it was actually a lot of fun because you incorporate the fact that it seems almost real world, like you're in a fab. You punch in the numbers, you do everything you should be doing in a reactor.
Hi, I'm Bill Brooks, a graduate student here. I programmed the latest HTML interface for the virtual CVD as well as done other updates to it.
One of the features of the virtual CVD lab is that students can measure wafers. They can measure the current one or remeasure one from previous runs. Users choose what wafers they want to measure as well as which points. They can measure the same points or different points on the wafers they choose. After measurements are done, they can view the data in the program or export it to Excel.
I was in a team of 3 graduate students, and we were given the opportunity in Dr. Kretsky's thin films class to use the VirtualCVD Reactor. So we made a simple model, and we came up with some parameters, and we were able to gain access to this VirtualCVD Reactor. And of course we put in the parameters, and we were kind of off because we made some assumptions that apparently didn't work in the real world. And so we went back and said, okay, what was wrong? We did some more research, found an article with a different type of model that we decided to follow. We improved the model, and then used that model to make more parameters and try again.
We developed the instructor interface as a way for an instructor to easily control elements of the project. In addition, instructional materials are available on the instructor interface so that anyone who's teaching has access to PowerPoint presentations of the core material, to worksheets for students to do, and to assessment materials.
One question people ask is, how did the students respond to the experience? And there's three things that come to mind. First of all, the psychologically and physically evident struggle they go through wrestling with the ambiguity. In other words, they're given a problem without a clear solution path and without any tangible physical things in front of them. And they really struggle with defining the problem, defining their metrics for success, and then agreeing as a team on their approach. Once they get rolling, typically they'll describe it, ironically, as being a more real-world experience, which is kind of humorous considering it's a virtual lab. But they really do believe that. They feel that they're taking the time to invest in optimizing a process to improve the results, which is something they would do in an actual job, as opposed to just accomplishing an experiment, writing it up, and be done.
I think the virtual chemical vapor deposition laboratory is a wonderful tool that can be used by instructors of all levels and many disciplines. We used it 2 years ago. We started using it in both the chemistry and the engineering classes, and we used it last year, and we're going to continue to use it.